Welcome to the next session of Simplex Method for LPP. Last class we have discussed maximization problem. Now let us see how minimization problem of LPP can be done using Simplex Method. Here is a question. Solve the following LPP using Simplex Method. Minimize z is equal to x1 minus 3x2 plus 2x3 subject to constraints 3x1 minus x2 plus 3x3 less than or equal to 7 minus 2x1 plus 4x2 less than or equal to 12 minus 4x1 plus 3x2 plus 8x3 less than or equal to 10 x1 x2 and x3 greater than or equal to 0. So this is the question for you. Okay. Now let us solve this. So as we know, inequality should be converted into equality by adding the slack variables, because here it is given less than or equal to. So that is what we are going to do first. So constraints, three constraints are there. So 3x1 minus x2 plus 3x3 plus 1s1 is equal to 7 minus 2x1 plus 4x2 plus 1s2 is equal to 12 minus 4x1 plus 3x2 plus 8x3 plus 1s3 is equal to 10. So with the constraints we have added the slack variables. Our question is minimization, right? Minimize z is equal to x1 minus 3x2 plus 2x3. So that should be converted into maximize. So z dash is equal to, just change the sign, minus x1. See here, x1 minus 3x2 plus 2x3. So just change minus x1 plus 3x2 minus 2x3 plus 0s1 plus 0s2 plus 0s3. The only thing is that z is changed to z dash, and the sign of each variable we are changing it as opposite. Plus becomes negative and negative becomes positive. Okay. And as usual, you have to add the slack variables with the coefficients 0. Okay. Now let us see how this can be solved. So this is the first simplex table 1. Column you have to prepare CB, CB and XB common. X1, X2, X3 are the variables. S1, S2, S3 are the slack variables. Okay. And these are the basic variables we have written. S1, S2, S3, coefficients of S1, S2, S3 in the objective function. XB is the constant, and for the first constraint, the coefficients of x1, x2, x3, s1, s2 and s3. Same way for the second constraint and for the third constraint. And then find zj. We know all this. Zj is equal to sigma of CB xi. Okay, here I is 1 to 3, ranging from 1 to 3. Okay. And then Cj, the coefficients of the variables in the objective functions, that is minus 1, 3, minus 2, 0, 0, 0. Okay. And then delta j, that is Zj minus Cj. Okay. So delta j we have to find, and we have to check whether all the delta j values are positive. Here one is negative. See, that means we have to continue. Okay. So this particular is the key column, as we know. This is the key column. And next find theta. Okay, xb divided by key column variable x2. So 7 by minus 1, that is minus 7, and you'll get this. Take the least positive value, that is 3. Okay, 10 by 3 is 3.3. So you have to take 3. Okay, this is negative, and 10 by 3 is 3.33. It will go like that. So the smaller value is 3. So take that, come to the intersection point, and that is 4. That is a key element. This is the key row, and this is the key column, and you got the key element. Okay. Now we know key element should become 1 and other key column values should become 0. Okay. Here, this was the previous table and this is the new table generated from this. So it is 4. And also one more thing, here x2, this is the variable of the key column, and s2 is the variable of the key row. As we know, s2 should be replaced with x2, right? So in the new table, simplex table 2, instead of s2 we have written x2. Okay, now this 4 should become 1. That means 4 by 4 you will get 1. Okay, same calculation you have to do for the complete values in the rows except CB. CB we are not, on CB we are not doing any calculations. Okay, that is XB. Up from here you have to do the calculation for all the elements. So that will become 1, and then next step is, after making the key element 1, the next step is make all the key column elements 0 with respect to the new row. Okay, this is the new row, x2 is the new row. So based on this, with respect to this, you have to make this value 0 and this value also 0. Okay, so first make any one. Here this is 0 and now this is also 0. Okay, this how can we make 0? This value, that is, suppose this is R1. We have discussed this in detail in the last class. Is R1, R2. This is R2 and this is R1. R2 we are considering this row, right? So minus 1 plus 1 will become 0, this one. So minus 1 plus this one will become 0. Okay, so that way you have to make the 0 and you have to do the calculations for the complete row, and then you have to make this 3 0 with respect to this one. Okay, so how to make this 0? This is row 3, right? Row 3 minus 3 row 1, row 2, row 3 minus 3 row 2. Okay, R3 minus 3 R2. So like that we have to do for the complete row, and then again Zj you have to find, Cj as usual you are having, and then Zj minus Cj. One thing I forgot to tell in the last table, that is Cj is the minimization objective function value, that is Z dash value. Okay, not Z value, Z dash. You might have noticed that the question was minimization and that is Z, and we have converted it into maximization, that is Z dash. So Z dash variable coefficients we are writing in Cj, then Zj minus Cj. Okay, here again this is negative. Okay, so you have to continue. So this is the key column, you got this as a key column, and xb divided by key column variable x1, so you're getting this, and the positive, least positive value, only positive value is 4, so take that intersection, this is the key element. Okay, again continue, make the key element as 1 and make the other key column elements as 0. Okay, these two you have to make 0, minus 1 by 2 and minus 5 by 2 you have to make 0, and this 5 by 2 you have to make 1. This is the previous table. Now you see this is 1, see here 5 by 2, this one. Okay, 5 by 2 into 2 by 5, that will become 1, and here minus 1 by 2, minus 1 by 2 should become 0 with respect to this one, right? So this is row 1 and this is row 2. So row 2 value you are making as 0. So row 2 tends to row 2 minus, not minus, row 2 plus. Okay, row 2 plus, here 1 by 2. So 1 by 2 into row 1. So that will become 0 because the row 2 value is minus 1 by 2. See this, minus 1 by 2 plus 1 by 2 into row 1 value is 1. Okay, this one. So this is 0. Same calculation you have to do for the others, and this also we have to make 0. How? This is minus 5 by 2, right? So minus 5 by 2 should become 0 with respect to row 1. So that is row 3. This is row 3. Okay. So the new row 3 value will be how? Row 3 value R3 is equal to, or R3 tends to how? R3, this is minus. So plus 5 by 2 into R1. Okay, here R3 is minus 5 by 2 plus 5 by 2 into R1. So 5 by 2 into R1. R1 is 1, right? So 5 by minus 5 by 2 plus 5 by 2, that is 0. The same thing you have to do, and you will get these values. And one more thing, here x1 was the column variable and s1 was a row variable, right? So s1 should be replaced with x1. See, now no s1, x1 is there. Okay, so 3 points only you have to notice, that is, while making the new simplex table, not the first one, when we are continuing. Okay, so when we are making that, first check which is the leaving variable and which is the entering variable. Based on that, write the variables. Okay, and then make the key element as 1, and after that make the key column elements as 0 with respect to this new row. This is the new row. Okay, this one is a new row, this one we made as 1, so this is the new row. With respect to this row, we have to make the other row values as, other column values as 0, not row, other column values as 0. Okay, so that is it. That is, first make the key element as 1 and then make the other key column elements as 0 with respect to this new row. Okay, now see Zj and Cj you are having, Zj minus Cj is all positive. See, check whether all are positive or not. So after checking, all are positive, so no negative, hence the solution is optimum. So you have to conclude. Okay, so for concluding, you have to take this x1, x2, s3 and xb values. That is b column and xb column we are considering. So here x1 is 4, x2 is 5 and s3 is 11. Okay, so x1 and x2 are there, that means x3 is 0. So substitute in z dash, that is maximum value. Okay, substitute in z dash, you will get 11. But our answer is, our question was minimum, right? Minimize. Our question was like that, minimization problem. So minimum of z, the original question. And then substitute, you will get minus 11. So this is the answer. Okay. So now you have done two problems. One is maximization and one is minimization problem. So if the problem is minimization, make it as maximization. Objective function, change the sign. Okay, z will become z dash, and that objective function you have to consider for Cj. Same way, nothing, no change. So find b, cb and xb. You will be having x1, x2, x3, s1, s2, s3 in this question. Take the coefficients from each constraints, enter it, find zj, cj you will be getting from the new objective function, that is z dash, find zj minus cj. If any negative value is there, continue. For continuing, row column, key column you have to identify, then key row you have to identify, intersection is a key element. Okay, then the key column variable, we are replacing the key row variable with the key column variable. Okay, so key row variable is replaced with the key column variable. Okay, and generate the new table, and after that make the key element as 1. So after that make the other key column elements as 0 with respect to this modified row where the key element was. Okay, so with respect to that key element, that which is 1. So with respect to that you have to modify the other key column elements. Only that thing you have to be careful while doing the calculation. Then find Zj, Cj, Zj minus Cj, again positive, again negative means continue if it is until the whole values of Zj minus Cj is positive. Okay, so do many problems for this, then this will be thorough. Okay, so hope it was clear for you. Thank you.